Okay, let's take a look at algebra proofs. Algebra proofs are kind of where we'll start. And to do some algebra proofs, let's look at some algebra properties first. I kind of have a bunch listed here. These aren't all of them and in the entire world, but it's definitely a good list of a lot of the things that you will see. So we have a reflexive property, which is to say that A equals A. We might use it in geometry to say that two angles are equal to line segments have the same length. We also know that we have symmetry in the world, right? So in an algebra sense, something to say something is symmetric is to say that if A equals B, then of course B also equals A. Transitive property is saying that if A is equal to B and B is equal to C, well then we can actually conclude that A equals to C, right? That's a major logical step that we use all the time. We could say that if angle A and angle B are the same measure, but we also know that B and C are the same measure, then we actually know that A must equal C, meaning they're the same measure. We also have substitution. So an algebraic substitution is to say that if we know A equals to B, or we know that like X equals Y plus 4, we can substitute that value in any other equation. And you do that in Algebra 1 all the time, right? We said like Y equals 2x plus 1, and then we could take that and we could substitute 2x plus 1 into Y into the other equation. We have addition, subtraction, multiplication, and division, which are pretty standard. So we know that we can add things to both sides of the equation, right? Well, that's really the property of an equality, right? We know what it means to be an equation. We know we can add things, we can subtract things, you can multiply things, and you can divide things. The only thing you can't do is you have to make sure you can't divide by 0. That doesn't really make any sense. But then also, you have like exponential properties, which means you can square both sides of an equation. You can take the square root of both sides of an equation. You can cube both sides, and it's still the same equation, right? It's a balance. We also have some old school rules like commutative, which says that the order doesn't matter, right? A plus B and B plus A is the same. A times B and B times A, it's the same. It doesn't matter whether you switch those, right? 3 groups of 4 or 4 groups of 3 is the same, right? Start with 3 and add 4, or start with 4 and add 3, you still get to 7. Associative is about the grouping. Again, it doesn't matter whether if you're going to do A plus B plus C or A plus B first and then add C, you're still adding all 3 of them together. And so the order in addition, or the grouping in addition and multiplication doesn't matter. Obviously, if this is a negative sign, well, it does matter which one you subtract. It doesn't matter the order as long as you could do A plus B minus C, or you could do A minus C and then add B to that result, and that would be the fine. Distributive property just means that we know how this works in multiplication, right? This is really just multiplication. There's no real difference there. We just know how that works with a binomial. And then later on, I certainly at some point will discuss what it means to be even and what it means to be odd. Not really today, but I just introduced it on this sheet. So this is a lot of the rules that you know. Probably some of the bigger ones are the transitive property. We use that a lot. We certainly use substitution, and of course the main operations in math, right? Addition, subtraction, multiplication, division. Okay, so let's kind of look through an example of, I think I got 4 problems here for us. So this is what it'll look on like kind of on the worksheet. So we have 4 problems, and we're going to use algebra to solve, but I want to emphasize that we're going to do it as a proof, which means I'm going to justify every single thing I do in every line. And so if I start with this and I end with a conclusion, I know that the conclusion was built on algebraic principles that we all know are true. Whether they're postulates or theorems or axioms, it doesn't really matter. But we all know the list of algebra properties I just showed you are all true properties. And so we can use those to justify each step. Remember, a proof is like a logical reasoning activity where you're going to go through. So the first thing I'm going to do is I'm going to add 4 to both sides of this equation. So my next line in this, I'm going to add 4 to both sides is this. How was I allowed to do that? Well, because I know the addition property is true, right? I'm justifying where I got the pink. I got the pink because I did addition, and I know I'm allowed to do addition. I added 4 to both sides of the equation. Now I'm going to divide 3. So I'm going to divide both sides by 3. and I'm going to get 7, right? Division, right? And maybe even in parentheses we do addition and say, hey, we added 4 to both sides, right? And then division, we divided by 3. And I know division is a property of an equality, of an equation, and so I'm allowed to do that. My next line is going to be, I'm going to subtract 2 from both sides. How did I know to do that? Well, or how is if the black line is true, how is the pink line? Well, because of subtraction. I know subtraction is a legal thing to do to an equation, and I subtracted 2 from both sides. And then I'm going to go ahead and get x equals 25, because I'm going to multiply both sides. Multiplication, multiply, and I multiply both sides by 5. Right? Do you see how I started with this? This was like the given, and I ended up that this was my claim. And my claim is true because I went from the given piece of information, which is given to be true, and I worked down, and I only used algebraic principles that we know are allowed. We are allowed to add, divide, subtract, and multiply. And so then I got to this claim, and I know then that that's actually a true statement. And again, in algebra, that's what we're doing, right? We're trying to find x based on that information. Okay, let's go over on this next one. Over here again, it's always about reverse order of operations, right? I'm going to get rid of the 5 first, and since it's adding, I'm going to subtract 5 from both sides. So the next line, subtracting by 5 is going to make that -3. How am I allowed to do that? Right, subtraction. And I'm almost running off the page. And I subtracted by 5. And then the next line is I'm going to get rid of this division by 3, right? I'm going to multiply, right? I'm going to use the inverse operation. So if I multiply both sides by 3, I'm going to get -9, right? -3 times 3 is -9, and this is multiplication. And I multiplied everything by 3. I'm justifying every step I do. Then I'm going to add 1. Adding 1 to -9 is going to increase it to -8, right? And that's addition. I added 1. And then I'm going to divide by 4. -8 divided by 4 is -2. Division, I divided everything by 4. Again, I worked down from the given to an answer, right? This was the given, and I used algebraic reasonings, right? I've justified every step I did is a true statement, right? I know I'm allowed to subtract by 5. I know I can multiply both sides by 3. I know I can add 1 to both sides, and I know I can divide. And the order in which I did these is based on order of operations, right? We're working with the furthest things away from the x. So let's get rid of the 5, then the 3, then the 1, then the 4. Okay, down here, very similar, you know, maybe a little more Algebra 2-ish, but the first thing I'm going to do is subtract 4. And I know I can subtract 4 because of subtraction. I can subtract 4. And then the next line is I'm actually going to take a square root. And I have to introduce plus or minus. And this is like an exponential property. Right, I really took the square root, an exponent property. I took the square root of both sides. I do have to introduce plus or minus, and that's probably a more in-depth conversation. But anytime you have a square and you take the square root of both sides, you have to introduce the possibility of a negative sign. This next line, I am just going to simplify. The square root of 49 is 7, and you might just say simplify, and that's just a mathematical fact, right? The square root of 49 is 7. And then I'm going to add 3 to both sides. Okay, and that's addition. All right, I added 3. And then my last step is I'm just going to look at both of those solutions. 3 plus 7 is 10, and 3 minus 7 is -4. And I just, I guess that's me just simplifying what it means to be plus or minus, right? That's just me doing the plus version and minus version. You can check your answer if you want, right? 10 minus 3 is 7. 7 squared is 49. 49 plus 4 is 53. And if you use -4, -4 minus 3 is -7, but -7 squared is still 49. 49 and 4 make 53. Okay, last one. The first thing I'm going to do is I'm going to get rid of that 1. I'm going to add 1 to both sides and make that 4, right? That's addition. I added 1 to both sides. Then I'm going to square both sides, and I know I can do that. Exponent properties, right? I square both sides. Then I'm going to divide by 2 and get 8, right? Division. Divided both sides by 2. And then I'm going to subtract 3. And I get my answer. And I know I can do that based on subtraction principle. Okay, so this is kind of like the first step in understanding what a proof might look like in a geometry class, but we're using algebra. And again, all of these equations you know how to solve from Algebra 1, but maybe you didn't actually go through and justify every step. So in a proof, we might be trying to prove angles are congruent. We might be able to prove triangles are similar. But we have to logically go from the given piece of information down to the answer or the conclusion. And so we started with this, we end with this, and every one of these steps working, we justify with a postulate or a theorem or a property that we know. In this case, all of these are kind of like algebra properties. Okay, hopefully this video helps you get started on algebraic proofs.